Dilations enlargement. This is taken from the website mathbitsnotebook.com. Dilations are enlargements or reductions. So if you see the word dilations or you see the word enlargements, it means the same thing. A dilation is a transformation that produces an image that is the same shape as the original but is a different size. So you can see in the diagram that we have the pre-image and then we have the image, which is a different size. In this case it is bigger. So we can see the image here is bigger, so this is an enlargement of the original shape ABC. A dilation creates a larger image. A dilation that creates a larger image is called an enlargement. A dilation that creates a smaller image is called a reduction. So if it gets bigger, it's an enlargement. If it gets smaller, it is a reduction. A description of a dilation includes the scale factor or ratio and the center of the dilation, sometimes also called center of enlargement. Right, so sometimes it's also called the center of enlargement. The center of dilation or center of enlargement is a fixed point in the plane. If the scale factor is greater than 1, then the image is an enlargement. It expands, it gets bigger. If the scale factor is between 0 and 1, the image is a reduction. It contracts. If the scale factor is 1, the figure and the image are the exact same size. They are congruent. The word dilate is often heard in relation to the human eye. The pupils of the eyes were dilated. As light hits the eye, the pupil enlarges or contracts depending on the amount of light. This concept of enlarging or contracting is dilating. So, dilations can be seen in a variety of situations. We can see it in photography. School or holiday picture packages offer the same photograph in a variety of sizes, from large to medium to small wallet-sized photos. Arts and crafts. Russian nesting dolls are a set of wooden dolls of decreasing size placed inside one another. After the smallest doll, each doll is an enlargement of its inside doll. Graphing calculator. The zoom feature will enlarge or reduce the reviewing window. Food service. Soft drink containers come in a variety of sizes. While some are different shapes, others are simply enlargements. So not all are enlargements, but some are enlargements of each other. Product logos can come in a variety of sizes, such as these pizza shop logos on their small, medium, and large boxes. Grow toys are sponge foam toys that grow when placed in water. Some grow quickly while others grow over several days. So let's now look at dilations in the coordinate plane. So most dilations in the coordinate plane use the origin 0, 0 as the center of dilation or center of enlargement. The center of the dilation will be indicated within the problem or within the notation. So the question will tell you to use the center of enlargement or the center of dilation as the origin, and this is what you'll do. So let's look at this example where they do a dilation with a scale factor of 2. So we see the pre-image, the original shape, A, B, C. And A has the point 0, 2, B has the point 2, minus 1, and C has the point minus 2, 2. So starting with ABC, they want you to draw the dilation of the image of the triangle with the center at the origin. So the center of enlargement or the center of dilation will be at the origin. And we know that the origin is 0, 0. And a scale factor of 2. Scale factor of 2. Sometimes we use K to represent scale factor, so K will be equal to 2. Notice that every coordinate of the original triangle has been multiplied by the scale factor 2. So to get the image, we're going to take the coordinate and multiply it by 2. So A prime will be 0 by 2, which is 0, and 2 by 2, which is 4. B prime will be 2 by 2, which is 4, and minus 1 by 2, which is minus 2. And C prime will be minus 2 by 2, which will give us minus 4, and minus 2 by 2, which will give us minus 4. So dilations involve multiplication. So once you have to do a dilation with the center at the origin, all you do is multiply each point by the scale factor. Let's look at another example where the scale factors are half. So we see the pre-image here, the original shape, and the original shape is A, B, C, D, this parallelogram. So we know that the points A, this is the point A, B, C, and D. So since the scale factors are half, and the center of enlargement is at the origin, and scale factors are half, so K is equal to a half. And the center is at the origin, so the center is at the origin, the scale factors are half. We're going to multiply each coordinate by a half, which will give us minus 1, 2, 2, 2, 1 minus 1, and minus 2, 1, as we multiply each of these coordinates by a half. And when we plot it, we'll see that we get a reduction of a half. Dilations not at the origin is not on your syllabus at this point, and you do not need to know how to be able to do this at this point. Dilations and similarity. Remember, we did congruent and similar triangles. So two figures are similar if one is the image of the other under a transformation from the plane into itself that multiplies all distances by the same positive scale factor. That is to say, one figure is a dilation of the other. So if you remember, when we did similar triangles, all these angles are the same, but the lines are ratios of each other. So when you do dilation, the shapes and the images are similar. All the other transformations you have learned, rotation, translation, and reflection, the images will be congruent. However, enlargement is the only transformation where the images would be similar. Okay, so let's look at the IXL exercise. It is 8th grade Q2, dilations, graph the image. So 8th grade Q2, dilations, graph the image. Please make sure you log in before you start the exercise. So they want us to graph the image of JKLM after a dilation with scale factor of 5, and it is the center of enlargement is the origin. So once we see center of enlargement at the origin, the first thing we could do is we take the coordinates. So M is the point, we read X first, so minus 1, 0. L is the point, 2, 0. K is the point, 1 minus 1, and J is the point, minus 2 minus 1. And the scale factor is 5. So therefore M prime would be, multiply everything by 5, we'll get minus 5, 0. L prime would be 10, 0, as we multiply everything by 5. 1 by 5 for K prime would give us 5, minus 1 by 5 would give us minus 5. And J prime, minus 2 by 5 would give us minus 10, and minus 1 by 5 would give us minus 5. So let us plot the image now. So we're looking for minus 5, 0, so that gives us M prime. We're looking for 10, 0. That gives us L prime. we are looking for 5 minus 5, and that gives us k prime, and we're looking for minus 2, sorry, we're looking for minus 10 minus 5, and that will give us j prime. On observation, we can see that the two shapes are similar, as in they have the same angles but different lengths. So more than likely we are correct. Okay, so let's submit that for IXL. Okay, so let's do for IXL now. So we know that M is minus 5, 0. So we go to M and drag out the term to minus 5, 0. L is 10, 0. J is 5 minus 5. And J is minus 10 minus 5. So we check to make sure the two shapes are similar, and we click submit, and as you can see, it is all correct.